Hello everyone, and welcome to this introduction module to the Procedural Asset Production Masterclass. In this video, we are going to focus on digital assets in Houdini, or HDAs, and how we can import them into Unreal. Alright, so here in Houdini, I've prepared a little example. And the first thing I would like to explain to you is what a Houdini Digital Asset actually is. A Houdini Digital Asset, or HDA, is basically a library file that is stored on disk that contains all the nodes and definitions necessary to load your tool into your scene or give it to someone else so they can use it as well. And we can also use this to import it into, say, the Unreal Engine. Now, these files can be saved either to disk as a HDA, or they can be loaded into your scene file as an embedded HDA. Now, HDAs can be reused because they're basically their own files, and they also have a form of version control built into them. Plus, you can also, of course, upload them to, say, a Perforce server and then have version control there. Now, they're very powerful because a HDA stored on your hard drive won't change unless you go ahead and open it up in Houdini, make changes, and then save the definition back to the file on disk. And if you save that definition to the file on disk, it will update all the other instances of that tool that are used elsewhere automatically, as long as those tools are matching to that definition and aren't actually open for editing at the time. Now we'll explore this later in a bit when I do an example on that. But first, basically the idea of HDAs is that you can create these tools that you can hand off to other people, and they can then update the tools themselves, or you can update them, hand them off to them again, and then they have the latest version of your asset. It allows you to create a procedural pipeline. They're basically the core of this. They're the core of a tool's pipeline, and that's what makes them so powerful. Now, this is especially true when we start combining them with the Houdini engine, which is the API for game engines that Houdini comes with. And when we import a HDA into Unreal, such as these, we can actually take our tools that we have from Houdini and run them inside of the game engines. So we simply have to import a HDA into Unreal and it will load, such as, for example, our building project over here, which we'll be working on in the second half of the introduction module. Let's go back to Houdini. Now, it's important to know that there are actually digital assets that come natively with Houdini. When we look at the nodes available in Houdini, they are also stored in library files on the hard drive, but we don't want to actually change these files. We can on some of them, but we don't want to, because this would cause all kinds of problems. If we change the definitions ourselves, then basically anyone who tries to load our own tools with these changed definitions couldn't use them because they wouldn't have those changes. Now let me quickly explain the differences between standard Houdini nodes and Houdini native digital assets. A standard Houdini native node is basically a node written in C++ or maybe VEX, and these nodes are basically encoded, so you can't change them anyway. There's no way to change these. And if I try to, I don't think I actually can. No, there's no way to change these assets. But if we look at some of the Houdini native assets here, like the color node and the mountain node, these actually have a little lock symbol next to them, meaning they're digital assets. And we can go inside of them and look at the different networks in here, such as all these wrangle nodes that are in here and attribute creates that are used to set the different values for the color when we use a color node. Now, if we click on this one and we open up its type properties, and I'll get to that in a minute, you actually see that there are all kinds of parameters available here. We have the inputs and everything is available. However, it's saved to Houdini's default sublibrary HDA, and you do not want to mess with this one. Don't mess with these HDAs, don't mess with the native libraries, ever. So how can we actually make our own tools if we can't adjust Houdini's tools? What if we want to make a HDA that acts like an existing node? Well, in that case, we have two options. We either nest an existing Houdini HDA inside our own tools, such as in this case, where I've created my own custom fuse node, by basically taking an existing fuse node and building it inside my own custom tool. So this is the standard Houdini fuse node. But on the top level here, I've wrapped it inside my own tool, which is stored as my own HDA file, and it's not in one of Houdini's default libraries. This is my own custom fuse node, or at least, I basically made a little simulation of it here. And what we can also do, of course, is instead grab the code from inside one of these native HDAs, copy it all over, and then save it into our own little subnet as our own tool. Now in this case, I've taken the color node and I've taken out some of its components so it can only color points. Maybe you want to do that to optimize the color node. I've done this in the past, but in the past the color node was way heavier. It's been optimized a lot, the native one. But in general, you can actually make your own tools based on the existing ones. Just don't save them to the same definitions. You need to save them to your own definitions. Okay, so now that we've discussed what digital assets are and what not to do with the native Houdini digital assets, let's go ahead and talk about how we can create our own digital assets. And for that, I first need to explain to you the types of assets that we are going to make in this course. In this course, we are going to focus on surface operator assets and object level assets. And the reason for that is simple. These are the ones we can actually import into the Unreal Engine, or at least as far as I have experienced. Now, they're also the most common type of assets that we can make, because most of the other assets are very context specific. We are generally not going to import a material asset into Unreal. Okay. What we might do, however, is create an asset in the geometry context that manipulates some kind of mesh in Unreal and applies a material to it. But this is still a geometry type asset. Anyway, let's not go too deep into that. The point that I'm trying to make is that I have two types of assets here, like this one, the SOP type asset, and I also have an object type asset out here. And both of these create two little primitive objects. The object type asset creates a torus and a cylinder. And then if I go to the geometry container, inside here, we create a sphere and a box. Alright, that's simple enough. But the reason I have two different types of assets is because each type has its own benefits and downsides when it comes to importing them into Unreal. Right here in Unreal, I have both assets instantiated inside my scene. And you can see them right down here. And both of them are outputting geometry, but they're doing it both in slightly different ways. Plus, when you start to import other types of information, like instances, such as for a building over here, which is these objects on the roof, these are actually instances and not meshes like the rest of the building, then, well, we start to deal with which type we actually need to use. Like, in this case, it's actually better to use the object level asset and not the SOP level asset. And let me quickly explain why. So back in Houdini, if we are looking at the surface operator asset, now the surface operator asset has a couple of great benefits in that it can be easily integrated into other surface operators. Like, for example, what we saw with this fuse node. This is a surface operator asset, and it's integrated inside another surface operator asset, or geometry type asset. So they can be nested inside one another, and this serves as utilities, like functions that we can use as little bits of code that we can use, right? Like, for example, all these nodes. They serve a function that's used to make our nodes work, that make our tools work. These are utility assets. We can also make standalone assets that do something that we can then nest inside bigger tools to make more complex tools. That's one of the benefits of the SOP level asset. Next to that, they come with their own inputs and outputs. So in this case, I have inside of this node 3 channels. 2 of them are generating a sphere and a cube. And then I have one input over here that's grabbing data from the outside that merges into output 0, and another one that takes data from the second input dot here, and then just simply feeds it through to the output. Now there's no real reason to do this under normal circumstances, but each of these channels here are separated from one another. And that means both data streams are also separate. So there are some benefits to that. It can be used to optimize what's being cooked when you have your node. And we'll be using this during the class quite a bit. However, one problem is that a SOP asset does require all the information that we send to Unreal to be merged into a single output. And that's where the problem lies, is because that means that we need to merge all of our data together. So if you have a very complex mesh or multiple complex meshes, we can't split it up into multiple pieces. It has to all come down the same channel, down the same pipeline, and merging that data can be heavy. Also, when we start to combine instances, such as the events on the roof and the mesh of the building, and then we start to combine attributes, things can get a little hectic, and we have to jump through several hoops to make this work. This is where object level assets come in, because object level assets actually use geometry containers or other types of containers inside to separate out the different meshes. In this case, if I just open up this asset, we have two objects and both are basically their own little element. This means that we can create two elements or multiple elements, multiple of these geometry containers, and each one outputs its own mesh. We could also do this with instance data, where we have one geometry container dedicated for outputting the instance information, or for instances specifically meant for blueprints, for example, in Unreal. Now, this goes a bit too far at this point, and I will talk about it a little bit more in a minute, but it's a very important distinction to make, because by allowing us to split our geometry like this, we can output data efficiently from multiple sources. We don't have to merge it, which is generally faster. But on the other hand, these types of nodes cannot be easily nested inside other service operators. They serve a much better purpose as the final wrapper for our tools, as the final tool container, rather than a utility asset or an asset we install inside another one. Now let's go ahead and investigate inside of Unreal what I actually mean. So over here in Unreal, I have these two different assets, and both are functionally the same. They both generate geometry, they both have mesh information, and they both have colors, which is vertex colors in this case. And if we look down the list over here inside Unreal, then we can see that we have a mesh, and then we here have a material. And this is the output for this particular node. So I'll talk about what Houdini does and how we can cook nodes in Unreal at the end of the video. But first I'd like to explain to you the differences here between the types of assets, right? So the left one here is the object level asset. Now by default it's outputting both elements out because we have two geometry containers. First we have the torus, and then down below we have the cylinder. And each one is its own object. If I go over here at the top of the node, we can see we have two static mesh components. And I can select them separately. And I can move them separately too. Though they both have the same pivot in this case, because they have the pivot from the tool. Now on the other hand, we have our SOP level asset, and this one has both objects merged into the same mesh. If I look inside the mesh, both parts are present here, so they're fused, right? They come out of the merge node. And this means that if I go ahead and grab my static mesh component, then I grab both of them and I will rotate both of them. There's no distinction here. Now it is possible to actually split this data, and that is by packing your meshes before you merge them. If I go over to Houdini and I look inside this asset, then we see that I have these pack nodes here. And pack nodes basically take whatever mesh data we have, which in this case is our mesh for our sphere, and we have all the point numbers and primitive numbers all here. If I look at the spreadsheet of this asset, we can see that all this data is present. There's not much data, but it's all there. Now, the moment we pack this sphere up, we basically put it inside of a wrapper, like shrink wrap it. And at that point, the only data that we're getting out of this mesh is whatever is being transferred through the pack node onto this wrapper of the asset. Now, by wrapping up an asset, we actually make it very efficient for Houdini to load them. And we can load a ton of packed assets into our scene, much more than if we had them as sort of fully realized geometry. And we can also unpack this geometry as well. We can easily do that using an unpack node. But we'll talk about this more in the course, because packing and unpacking is actually something that's very useful. But when we pack data and we send it to Unreal, and we can do that by using the toggle on top of this asset, then both our objects become packed objects, and both of them become separate packed objects. If I look and I actually see the little indicator for the center of the object, you can see that both have different numbers. So this one's number 1 and that's number 0. This means that if we go to Unreal and we turn on the pack option on this node, let's go and find our parameters up here under the asset, and then we scroll down and we find the pack each object button. Then now, once it's finished cooking, we can see that we now have 2 object components being output by Unreal. We have the box right here and the sphere. And if I go ahead and refresh this mesh, we have 2 components now. So it is actually possible to output SOP level assets as split up components by packing the objects. Again, there are other considerations why it's better to use object level assets when you're creating an asset for Unreal. But that's not always the case. It just helps you organize your data better. It helps you process it better. So there's benefits and there's downsides, right? So next, let's go ahead and create our own tool, right? So now we've had a look at what the SOP and object level containers actually do, both in Unreal, and what their benefits and downsides are. And now let's actually create our own. So over here I've created a little example file where I have a grid and then my own subnet. And this is going to be a SOP type asset. And I've already set up all the interface. So we have inside a mountain node, which is linked up with the height and the scale, and then we have the color as well. So it's very similar to what we had in the last video. Let's create an output node on this one, and let's plug this in. So right now we have our data ready. Our spare parameters are already set up. We have our controls, they're working. And what we can do now is turn this into a digital asset by right-clicking on it. And then we can say create digital asset down below. When we do this, we open up the create new digital asset dialog. Now in here we have 3 options. The first one allows us to give the name of the node that other nodes will reference. So this is the internal Houdini reference name for the node. And then the one below is the label, which is the nice name of the node. So what we'd see here. Then below this we have of course the save location. Now by default Houdini will try to save this in the OTL folder inside of your My Documents folder under the current Houdini version that you're running. And then it will try to save it to, well, probably your own system name and then the tool. So in this case what I'm going to do is I'm just going to take this name and change it around a bit. So it says mytool.hda. I'm going to copy my tool from the label and paste it inside the operator name. And let's remove the capital M. Okay, so now the names are configured and let's click accept. And what this does is it opens up a new dialog window. And in this dialog window, we can basically configure our digital asset. This window has all the controls necessary to configure our asset. And before I continue and show you the operator type properties window here, let me show you what happened to the file that we just saved out. If we look on disk, you can see where our save path was. We now have mytool.hda, basically the library that we just created. And this is a Houdini Digital Asset file. Depending on your version of Houdini that you're running, you will get a HDA file, a HDA limited commercial file, or a non-commercial file. Now let's have a look at the edit operator type properties now that we have our tool. Now I'm going to close this window first, and I'll show you how to get it. Because in order to retrieve the type operator properties, you need to right click on a digital asset, so an asset with a lock symbol on it, and then you can go to type properties down here. If we click on this, we open up the type properties for this tool. Now this tool is currently loaded from my hard drive. It's installed into our scene, and we'll look into that in a moment. And when we make changes in this window, we are effectively changing the file on our hard drive, the very definition for this tool. And the definition is stored up here. So when I say that this tool is actually installed in our scene, it means that we can bring multiple copies of it into our scene file. And we can call them from the library file on disk. If I press tab and I type my tool, you'll find it right there. If I press it in the scene, then now I have a second version of this grid asset, and it will do the same thing. All its default values will be set. So what we did originally is that we had a color node and a mountain node, and these were pre-configured with spare parameters, and then we converted those into a new asset. So all the parameters were upgraded to the asset level. So now they're right here and they're pre-configured. And we'll look into that right here. But first let's have a look at the basic tab. So the basic tab, like I said, allows us to set the name, but it also allows us to configure how many inputs this node has. In this case it has one input and one output. We can change this to say 2 inputs and then 2 outputs. And if I click apply, it will apply it to both nodes in this case, because this node is the one we just saved to. You can see that right here. It's called my tool, and the operator we're currently editing is my tool. And then the one on the left is locked, meaning that it's matching the definition on disk. It's not unlocked. And with that turned on, this node will always match whatever changes we make on the right. That's very useful. If we have 2 tools in our scene, one's locked and one's unlocked, and we make changes to the unlocked node, then the locked node will always follow along. That's the benefit of digital assets. You can duplicate your code and it will keep updating itself. And there are some caveats to that, but we'll cover those in a moment. Now before I look at the parameters over here, let's add a unique icon to this node. Now we know that this node is a mountain node, or at least it has the function of a mountain node. So let's go ahead and open up its type properties. And here we can see that the icon of the mountain SOP, the native Houdini digital asset, is called SOP_mountain. So I'm going to copy that. And then over here in our own asset, I'm just going to paste it over here and replace the subnet one. If I apply this, then now our node is going to get a mountain node icon. That's always nice. You can add your own icons there. We can even set a default color, but that requires a bit of scripting. We'll get to that later in the course. Okay, so next, let's have a look at the parameters tab. And the parameters tab in the type properties window is very similar to the one that we can find inside the edit parameters interface. Except this one adjusts the parameters on the digital asset itself, not on the node. Now we'll look at this one in a bit more detail in a moment, but let's continue on. Now the node tab allows us to set certain exceptions on parts of our digital asset, different nodes in our digital asset. And this is important when we're dealing with Python, because some Python scripts require certain nodes to be editable even when the asset is matching its definition. We can also give it different sizes for the units inside of the tool as opposed to the global unit scale inside the scene. And we can specify here which handle the tool is using. So if we have a custom handle for our tool, which we can do with Python viewer states, a topic we'll discuss much later in the masterclass, you can do that here. You can set this here. So this next tab here, the input and output tab, allows us to change the names of the various dots on our nodes. So in this case, we have the input subnetwork input 1, and here's number 2. And then down here we have the output dot, which currently doesn't have a name, so it just says output 1. If we want to customize these, we can simply change the names in this field. So let's call this one my input 1, this one my input 2, and then for the output dots, right now we only have one available because we only have one output node to actually provide an output from. Let's call this one my output. And normally you could name these based on what type of data you're providing. So if we need to provide a grid on the first input, we can say grid input, and then the second one could be your manipulation curve input or something like that. But if we then go and apply this, now you'll see that the names have changed. If we hover over them, we now actually have the names visible. So that's good for tooltips, basically. Then here we can specify a help card for the node. We can type our own custom help card in here, or we can go ahead and provide a URL. So if you create your own custom asset, you can provide a URL, and when you click on the help button on the node here, you should get that site. You will get the URL and you will open up the site that this leads to. So if you ever publish your own tools or you have it in your company, it can lead there and then people can see how the node works. And the next tab I want to discuss is the scripts tab. And I'm skipping the code tab because there's not much I can do here. But under the scripts tab, I have the ability to add my own custom Python scripts. And if I add an event handler, then I can add different types of Python script modules, including just a pure Python module that we can trigger using different means. But we can also add Python scripts that execute when certain conditions are met, such as when the node is first created, when we update the node, or for example, if we install the node or even uninstall the node. And this can trigger Python scripts to run. So let's say we trigger an onCreated event. Then in here we could write a little Python script that changes the color of our node. So whenever we drop a new node in our scene, this script can trigger and it will change the color of our asset automatically. So let's say we can make it yellow, for example. Then this tab, the interactive tab, allows us to create custom handles. And we'll go into this in the later modules of the masterclass, where we cover heavy sessions of Python. And this is very powerful. We can create very interactive, user-friendly tools using this. Python viewer states, as they're called, are particularly powerful, but require a bit of an understanding of scripting. So we're not going to look at that at this point. Then in this section, the extra file section, we actually have the ability to upload files, such as textures or models, into our HDA file. And we can then reference those files from inside the HDA. I don't do this too often because it actually bloats the size of our HDA file, but it basically acts like a zip file for external files. We could even save other HDAs in here, but in general, when you want to import HDAs into Unreal, it's better to have one tool per HDA and not to nest them inside one another like zip files, basically. And then this last tab here allows us to control what happens when we actually save changes to the node. For example, we can actually save our spare parameters on here. And we'll talk about that in a moment, about what the difference is between spare parameters and the parameters on our node in general. So under the parameters tab, we have the ability to define our own parameters, of course. And these parameters are actually the definition of the parameters for this asset. And any changes we make here are going to be saved to the tool. So let's say I go inside of the tool and let's add a transform node. And if I plug that in, let's go ahead and grab some of its transform values. Let's drag in the transform and the rotate and the scale. And let's add in a separator to keep it all neat. Okay. Now if I click apply, we see that the tool has been updated and I now have my transform controls here. And I can use them, of course, to manipulate the position of our grid or rotate it. And the tool on the other end, because it's meshing definition, has updated as well. But now here's the catch. If both nodes are unlocked, however, let's unlock this node. So now that both nodes are unlocked, we actually have to be careful about what we do. Now at this moment, both nodes were actually matching the same definition when I unlocked them, so it's fine. But the moment we go into either one of these nodes, and we go and say disconnect the transform node, then on the left we no longer have the transform node and it wouldn't work, right? On the right, however, this change hasn't been loaded in yet. It's still loading its own local definition. It hasn't been matched to the file on disk, and we can still use the transform information. So now if I save the left node, I will save it with the transform node disconnected. If I save the right node, I will save it with it connected. So you have to be very careful about which nodes you're going to save. If you have multiple digital assets open at the same time and you're working on one, don't go and accidentally start working on the other one and then save out one and lose half your changes, right? That's something that's going to happen to everyone, but I'm just going to warn you right here and now, be careful when you have multiple digital assets of the same type open at the same time. Watch out for that one. But okay, so let's go ahead and undo our change. In this case, I want to keep the one with the transform connected because I don't want to break my little tool. And I'm going to save this asset. This will overwrite the definition on the hard drive. And then we can match the definition on both nodes. And now both nodes will have their transform nodes connected back up, and they will both work. So this is how we would go about fixing that situation, right? Just observe what you have and then try to select the right node and to save it out and then match both definitions. Now, if you recall, before we created this digital asset, we actually had a subnet with spare parameters on it. And these spare parameters were created using the edit parameters interface. But as you can see, all the parameters that we originally had have been converted to native parameters of this asset. They are part of the digital asset definition. And these two windows are very distinct from one another. Both allow us to create parameters on the node, but the left one here creates them on the digital asset, and the right one creates them on the node specifically. And these are spare parameters, and they can be easily deleted if we're not careful. Whereas these ones are saved in the definition and will stay on the node. So when you create interfaces on a node for a digital asset, you have to use the type properties window. If you create a parameter over here on the right, so let's say we add a float value or a few, and we accept that, then you can see we've added a couple of parameters down here, but these are spare parameters, and they aren't present on the other asset on the left, even though both assets currently have their definitions locked. Plus, if we click on the gear icon on this node, and we then go to delete all spare parameters, we will remove every single spare parameter that we've added to this node. So that's important. Also, when we edit the tool itself, let's say we undo this change, and we then go ahead and make some changes to our asset, like say let's add like a separator maybe, and then we apply that. And we need to make sure that the node is unlocked to do this, so let's go ahead and unlock and save. Then now it's going to tell me you had spare parameters on this node that you're trying to save, or one of the assets in your scene has spare parameters on it. And what do I do with them? Because do I delete them? Do I keep them? Do I try to keep our layout? So in this case, I can say no changes at all, leave it as it is and try to keep going. And that's the recommended option. We can also revert the layout. And that's because we changed our layout by adding a separator to this node, or we can simply destroy them. So let's go ahead and, well, say no changes like it recommends. And then if we click apply, it will actually give this warning again. So, you know, this isn't going to go away. We have spare parameters on the node. If we try to change the definition, it will want to know what to do with them. So yeah, putting spare parameters on a digital asset isn't the best choice, if you ask me. It's better to put them somewhere else and then just reference them to the node, for example, because you're not going to use them inside the node anyway. And that's another important thing to know. When you create a digital asset, any of the references inside of this node need to stay local inside the node. They cannot go outside the node or Houdini will give you warnings. And worst case, your node will break, right? It won't work. So let's say I grab a null node here. And let's create a spare parameter on that null node. Just a simple float, for example. And then let's grab that float, go inside of the asset, and let's link it to the uniform scale of this transform here. Now by default, it's going to disappear on us because this value is set to 0. But we can actually control the asset this way. It's not like it won't work. It's just that the moment we try to go inside the asset and save our changes, Houdini's going to give us a warning. Hey, a selected subnet has references to nodes outside of it. And then it tells us which reference it is and where it's going. Do I want to save anyway? Now, if you have a lot of this, you can get a very large list. You can save it to a log if you want and then read it through in a text editor or something. In this case, we know what's going on, so let's click OK. And then we can go ahead and maybe grab this node. Let's copy this, move it inside of our network, and then let's make this reference over here inside. So now we should have a dependency link inside the network, and this is legal, right? This is allowed. So now I can save it, and there's no errors. Now there are ways to link up parameters through the interface. Of course, you can create your own parameters. Other ways to do this is to promote values through the parameter interface. If you want to link one node to another, then you can do that by creating a, let me see, where is it? Operator path. So an operator path will allow us to grab a node link. Then a node inside of this network can look to this operator path. And then this operator path can grab a reference to a node outside here, like this fuse node, for example. So we can use the interface to create links between the inside of a network and the outside of a network safely. Alright, so before I continue, I quickly want to show you how we can install an asset into our scene. Because while we can create assets in our scene, and they will be installed in the scene by default at that point, if we want to bring other tools into our scene file, say from other projects, then we need to go ahead and install them first. We can do this through the File menu, and then we go to Import, and then under here we can find Houdini Digital Asset. We can also find this under the Asset window as well, here under Install Asset Library. Now, what I would like to do is install one of the tools from my masterclass. Now, I've been working hard on developing different tools and different utilities that we'll be using in the different modules of the masterclass. So I have a large range of tools at this point that we'll be building. Now, we're not going to be building all of these at once. We'll be doing it gradually over the course of the masterclass. But up here I have a tool called the Util Polyslice version 2, which is my most recent version of the Polyslice. And this is a custom utility that can cut geometry, and I want to install this one into my scene. So once I have my path specified, I can tell it where I want to install it. In this case, I want to install it into my current HIP file, but I could also install it directly into my scanned asset library directories. This one basically means that I believe it should load it automatically in other Houdini sessions. but by installing it in my current HIP file only, I'll only have it available here. We can specify some other advanced options down here, such as if the tool should give preference to this library, if there are multiple libraries of the same type installed. We'll look at this in a moment. And there's some other ones as well, such as if we want to show the library contents, and I actually need to click this to update this, because here we can now actually see what tools are part of this HDA. So let's go ahead and install this. Now the tool has been installed into our scene, and if I type poly slice into my window here, I can then go ahead and start using it. So I'll quickly give you a demonstration on this one. If I grab a box object, for example, and I grab a grid, I can then plug these together. And I need to configure it so it works on polygonal surfaces. And now, based on my cutting grid that I have here, it's going to cut this particular box into pieces. So this is one of the tools that we'll be building during the course, and it's a bit more robust than several of the other nodes in Houdini. Now I'm not going to go too far into this particular node right now, but this will be part in the second module of the course, and then we'll upgrade it later in the course as well. Now next, I quickly want to show you how we can manage our assets that are stored inside of our scene file. If we right click on any digital asset, down below we can find the Show in Asset Manager button. When we click on this, we open up the Asset Manager. And this Asset Manager allows us to manage a couple of different things that are very important about our nodes in Houdini. Firstly, it allows us to see every single library that's currently installed that contains digital assets. So in this case, you can see we have our scanned asset libraries right up here. And these contain all the native libraries that Houdini is using for its own nodes. So don't mess with those, okay? But we can also find the labs assets right here in this package. So this is where the labs nodes are located when we install the SideFX Labs toolset. And then down below, we have our own custom assets. So that includes, for example, the fuse node that I have over here, my custom fuse. We have the point color. And then we have my two test assets that I'm using for Unreal. So the SOP level and the object level asset. And finally, we have my tool. So this is where it's currently installed. Now these assets are currently installed to my scanned asset library directories. And what are those exactly? Well, a scanned asset library directory is a location on your hard drive that Houdini will always look at when it boots up to find the assets and any latest changes. Any other nodes have to be installed manually into your scene file, but then they will always be present. They will be installed here under the current HIP file. But scanned asset library directories are always found. And one of the default paths for those, of course, is your documents folder. But you can also have it inside your project folder if you created a project, and then you'll find it under the projects OTL folder, usually. Likewise, if we go to our settings or our ini file for Houdini, we can also manually configure more scanned asset library directories as well. This is very useful because it means that any files installed in these folders will always be loaded by Houdini. Now next, let's have a look at what it means when we have more than one copy of the same asset installed into our scene, which can actually happen. In this case, I have 3 versions of my Unreal Object Test asset loaded in my scene, and functionally they're all the same, or at least they should be unless you've made changes to one of them. Now these two definitions, the top one and the bottom one, both load from the same file. So if we make a change to this one, it will always save it back to the one on disk. So that would be the asset right here, this one. But this last one here is an embedded file. And when I mentioned initially, when I talked about HDAs, that we can actually embed them in our scene file, This is what tends to happen when you remove every single copy of a digital asset from your scene file without actually uninstalling the node over here in your node network. And what Houdini will do at that point is create a copy of your node when you deleted the last version and save it as an embedded file. This can also sometimes happen when your scene crashes, when it has to try and recover a file. Now the problem is that if you use a definition on your scene file itself as an embedded HDA, then it isn't going to save any changes to your hard drive. It's only going to keep it stored inside of the scene file itself, inside of the HIP file, which is fine if you want to do this, but in general you don't. So normally it would actually be better to uninstall it, right? Now, in order to manage which file is currently being loaded, Houdini actually has a default priority. If we go to configuration, we can actually see that by default it will give preference to files or definitions with the latest date. And also it will try to make sure that it uses the files on disk first. Now if you want to control which definition we're actually loading, then we can do that up here in the configuration tab. And if we scroll down, we can find the asset bar. And if you turn this on to display menu of all definitions, which it isn't by default it will be hidden, then you will see up in the top right that when we have an asset selected, it actually shows us a path up here for the asset and then where it's currently being loaded from. So if we have multiple digital assets loading from different locations on our hard drive, or if we are loading from an embedded file, then we can find them up here. And we can change them up here as well. So in this case, if I go ahead and switch this to the embedded state, then every single digital asset in my scene with this definition is going to start loading from that file here, the embedded version. If I switch it back, it will load the latest version from my hard drive. Now in general, you don't want to keep embedded files around unless you explicitly want to do so. So I'm just going to grab this one and I'm going to uninstall all embedded files. And this will give me a warning that I'm about to remove a library from my scene. I'm going to click OK, and now it's gone. We could also have right-clicked on the library itself. Now we do have another definition up here as well under the current HIP file. And I have a little warning I need to give you here. When you try to uninstall tools from your scene, be careful which options you choose. Always use uninstall. Do not use delete. Because down here you can do all kinds of things to your definition, to the actual tool, and how it's defined inside of the HDA. Inside this manager, you can mess with that information. And if you click delete and you click OK, you will effectively remove the definition of your asset inside of your asset on the hard drive. Be very careful with that, because you will destroy your tool this way. If you want to uninstall a tool, you right-click it and you say uninstall. And doing this will remove the library from your scene, from your current HIP file, but it won't actually destroy your asset. Now in this case, it's still installed down here, so that's safe. And with that, I think we've covered most of what I want to show you here. So at this point, let's finish this up by taking our little grid and let's import this one into Unreal. So we have my little grid tool up here, and right now this is a simple surface operator asset, and it's taken an input as its driver. Now if you were to bring this into Unreal, we could use it to manipulate geometry, but personally I don't do this too often. Instead, what I normally would do is either use it to generate geometry and use these types of inputs as a handle or manipulator. Now instead, what I'm going to do is I'm going to grab my grid and I'm going to plug it into the node at the top here, like so. And now we have a fully functional digital asset with a couple of defunct inputs here. Now, since they're defunct, I'm going to go to the type properties, go to basics, and I'm going to change the minimum input requirement to 0. Now it means that the tool will be able to run even when there's no inputs, because right now we do not need those inputs. And we could actually remove them, but I'm going to keep them for now. Now next, now that we have this tool, we can save it out. And let's go ahead and load this into Unreal. So now that we are inside of Unreal, let's go ahead and first make sure that our Houdini engine session is running. So up here on the top, we can find the Houdini engine dropdown. And if it isn't running, you can create a new Houdini engine session right here, assuming that the Houdini engine is properly installed. If you click on this button, then the Houdini engine will start booting up. And the moment it's ready, we can start dropping tools into our scene and manipulate them, such as our buildings or these cubes. But in our case, we have our own tool to import. So let's go ahead and grab our OTL folder and let's drag our tool into the content browser. Then we can grab the tool and simply drag it into our scene. And as long as the Houdini engine session is running, and the tool of course is not broken, it will generate geometry. Now if you have a lot of geometry, this might take a while to start up, but in this case our geometry is pretty simple, so this didn't take very long. So here we go. Now we have our mesh inside of the game engine and everything's working, right? Now let's see how we can actually manipulate this mesh. First up top here we have the Houdini engine controls, and we'll have a closer look at this in a moment. But then further down we have the parameters. And the parameters are the same ones that we set on our tool in Houdini. In this case we can change the height value, and when we let go of our slider, we update the asset. This is because we are triggering a cook on our parameter change up here. If we don't have this turned on, then we can go up here and click on recook after we shifted some parameters around, and this will reactivate our cooks. So we can do this manually as well. We can trigger it here. But let's keep this on. And then next below, of course, we have our transform values. These should still work even though we are inside of Unreal. So our terrain is currently being moved somewhere across our screen. But since it's very hard to see what we're doing, I'm just going to leave those alone. And then here we have our color value. Now I've noticed that the color parameters don't properly work inside Unreal, at least not as far as I'm aware. And that's a bit of a bummer. It might be fixed in the future, I don't know. But let's go ahead and change this parameter. And that means we need to update our tool. So if I go back into my Houdini session, let's go to my tool here. And now let's open up the type properties. Go to my parameters. And then we find our color parameter right here, which came from the color node when we promoted it up. Now I want to change this from a color parameter to a vector float tree. And when we do this and we apply it, well, we no longer have our color swatch, but now we should be able to change this inside of Unreal safely. Let's go ahead and make sure it's saved. When we change the parameters, it should have updated, but we can do it here under save node type as well. And now in Unreal, if we click on the node, right click, we can now import our changes. So let's do that. This will have imported the changes to our HDA. And now if we go to our asset in our scene, our instantiation of our asset, we need to click rebuild this time. Cook won't do it. Cook won't update the interface, but rebuild will. So if I click on that, now you can see that my color values have been changed, and now I can actually modify them. So let's say I want to make the red color 0.5 and the other one's 0. So we can make our terrain a bit of a burgundy red or something. Alright, this is disturbing me. Let's change it back to something else. Alright, so now that we have this, we can change our parameters. We have our ability to recook. We can also go ahead and reset all our parameters right here. And then finally, we have the option to bake out this mesh. Now we'll look more into all this process later when we are actually working with our main building tool. But if we click on bake, the Houdini engine will actually take our mesh and output it as a static mesh in Unreal. Because right now this thing is still a Houdini asset that's constantly being updated by its parent asset component. Whenever this tool recooks, the mesh inside gets destroyed and regenerated. So we don't want that, of course, if we want to use this mesh somewhere else in our Unreal session. So to fix that, we can click on bake, and let's say we need to make sure we bake the actor, and this will bake out the mesh. And now what has happened is that we have made a duplicate of the mesh from our digital asset located in the same location. So here's our asset and here's our copy. And we can have this asset and we can move it somewhere in our scene. It's now a permanent addition to my files. And if we then go ahead and look on the file in its file location in Unreal, we will find it in the Houdini engine bake folder. So we can of course grab it from here, copy it somewhere else. At this point, it's a mesh we can just play with, right? So at this point, we have pretty much finished up the video about digital assets and how to import them into Unreal. Again, quite a lot of things to unpack. But I think it's very important that you understand digital assets. So if you don't quite get it yet, maybe watch the video again, or keep watching and we'll try to do this on the fly when we actually do the main building assignment, okay? When we do the foundation assignment. Now in the next video, I actually have another video lined up that's about creating clean and organized node networks. So how we can color our nodes, add labels, add names, the whole works, right? But for now, let's call it quits on this video, and I hope to see you in the next one. Have a good one.